camera. Inverse variation. In order probably to get a grasp on the inverse variation thing, you should go back and think back. We talked about direct variation. Let's just put that off to the side so you remember it here. And if you look in your notes, somewhere in your notes, you have that the direct variation equation was y equals k times x. I don't know if you remember that or whatever, but I can tell you we did it. And what that meant was this. When things vary directly, what do? For example, one would hope that the amount of time you spend studying varies directly with the grade that you get. Okay, direct variation, if you remember, Steph, was?
Like goes up the same amount.
Exactly. As one goes up, the other one goes up in a proportional amount. Okay? You know, the amount of time you drive compared to the distance that you go, the more time you drive, the more distance you go. Well, that's direct variation, and that is this equation. Well, inverse variation, children, is the opposite. When it's inverse variation, it's one goes down as the other goes up in proportion. One goes down as the other goes up. Okay, one goes up, the other one goes down. And the equation that you use for that is just a little bit different. It's got some of the same things there. It is this. It is y equals, make sure I get it right before I, k over x. Y equals k over x. And by the way, the k was the constant of variation, if you remember. Like if you were going 10 miles an hour, you would use 10 for your constant variation. The other formula you want to have written down is this one. It's the product rule. So if you hear those words, the product rule, you'll love this one. It is x1 times y1 equals x2 times y2. Product rule is x sub 1 times, I guess I just write it like this, y sub 1 equals x sub 2 times y sub 2. This is the product rule. These two formulas right here will get you through most things in inverse variation. Because here's what they will ask you. Let me find it here. Here is an example problem. If y varies inversely with x, if y varies inversely with x, y equals 3 when x equals 12, y equals 3 when x equals 12, find x when y equals, what is it about, 9. Now before we attempt this sort of thing here, I just want you to think about this. Remember with inverse variation it's opposite. As one goes up, the other goes down. So if y went from 3 down up to 9, what's going to happen to x? It's going to go down because it's inverse variation. You know, if it was direct variation, if y went from 3 to 9, you know, your constant of variation would be times 3. It went up by 3, so x would have to be 36. But it's not. It goes the other way around. And you want to use this little rule right here to figure out what that is. And it's pretty simple. You just pick these to be the sub 1s, pick these to be the sub 2s, and just put them in the little formula. X sub 1 was 12. 12 times y sub 1, 3, is 36. And that equals x of 2, which we don't know, times 9. So you have 36 equals 9x. What does x equal? X would have to equal 4, or x of 2 equals 4, which makes sense. Because y went up, x goes down proportionally. Okay. A way to think about it might be this. If y goes up by a multiple of 3, x goes down by a division of 3, which is what happened there. It went up by multiplying by 3, so x has to go down in proportion down by, like, dividing by 3, if you will. Let me look at another problem here. There's got to be something here. Or how about this one? Write the inverse variation. This thing is not working very well. Write the inverse variation relating x to y x to y if when y equals 8 and x equals 3. When y equals 8 and x equals 3. Anybody have a clue as to how that's going to work? Now this one, since you're only given the y and the x and you're supposed to write the relation there, you think of that little thing I give you, y equals k over x. Plug in the numbers because you want to figure out what the letter k is. Okay. So if you do that, and you stick these numbers in for x and y equals 8. This is k over what, 3?
Yeah.
How would you solve that for the letter k? How would you solve that for the letter k?
Let's call that.
Sure, you could pretend that this is a fraction, or you could make it a fraction, and then it's just cross multiplication. 1 times k equals 8 times 3. So the equation you have is what? The equation you get is y equals 24 divided by x. That would be this written out here. By the way, another form of this would be what? Another form of this same equation would be k equals xy. Because I just did the same thing with this, y times x equals k times 1, so k equals xy. And then the book says, believe it or not, take this and graph it. How would you graph that on a number line? Or graph it on a coordinate system? Not bad. Probably the best thing I would do in this case, because we haven't dealt with stuff like that very much, is make a table.
Couldn't you just multiply 8 times 3? Or do you have to do it?
Could I just multiply what?
8 times 3?
I could have, yes, and that's what I did.
But like, it's a
Right off the bat?
Yeah.
You could have, but I want to show you how it's mixed up there. So if I have this equation, y equals 24 over x, I'm going to pick my x numbers. What numbers would I probably want to pick?
1, 2, 0.
Things that go evenly into 24,
Oh.
right? So let's just do negative 2,
3,
positive 3.
6.
I can't pick what? I can't pick 0. Why? Because you can't have 0 on the bottom of a fraction, so 0 is not an option for me to pick. So I will pick 6. How about negative 3,
4.
4? What do you suppose the graph of this is going to look like?
Very exact.
A line. Super. I'll go like this. Like a way.
Well, first of all, it's probably going to have a break in it. Why? Because you can't have a 0. So when you graph it, when I graph it like this, I can't get a point here at 0, but everything else I can get. Let's do this is what? 12, or negative 12, positive 8, positive 4, negative 8,
It is negative.
positive 6. What? No, just 24 divided by -2 is -12. 24 divided by 3 is 8. 6 divided into 24 is 4.
Okay.
I actually did the problem there. So here at -2, it's -12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, I put that right in the word thing. 3 was 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 6 was 4. 4, 5, 6, 1, 2, 3, 4. -3, -8. -3, 1, 2, 3, 4, 5, 6, 7, 8. 4 comma 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Can I get some other ones? What else haven't I used?
Oh gosh.
I want something over here. -4, -6, right? 1, 2, 3, 4, 5, 6. Here's what this actually looks like. If you were to graph this out, it would look like this. And it would look like this. Oops.
I was right.
Where these lines, neither one of these lines would ever cross either axis. They'd just be little round things that would come close to the axis but never ever touch it. Inverse variation.
That's right.
Isn't that slightly freaky?
Are they gonna ask us to graph them?
What's that?
Are they gonna ask us to graph them?
They might.
Hey,